Okay, Algebra 1 class, we are going to go over lesson 3.3 today, which is on standard form. If you recall last time we talked about slope-intercept form. Again, standard form won't be completely new to you, but we will probably cover a few new concepts or maybe a few new tricks that will allow you to understand it better and maybe graph the equations of these lines a little bit easier as well. So standard form of a linear equation, it's simply another common way to write the equation of a line, right? Just like last time, we have to ensure that our data have a constant rate of change, right? Because it has to be a line before we can write the standard form or slope-intercept form for that matter. So this standard form, you might recall, is written as ax plus by equals c, and you'll notice we still have an x, we still have a y. Those are going to be our variables. And now a, b, and c are all going to be integers, which means they can be any, we can't have fractions. We're going to have whole numbers or zero. However, a and b cannot both be 0. Okay? One of them can be at a time, but not both of them, because as you can tell, if both a and b were 0, I would simply have 0 over on this side. Okay? So, and I wouldn't have any x or y value to be able to get the components or the ordered pairs that would make up a line. So this a, this b, and this c must all be integers. So any whole number or 0, okay, can be negative or positive. Alright, so let's, with that taken into account, let's take a look at these 4 equations right here, and let's decide to ourselves, are these in standard form? Okay, so I want you to take a second and do those 4 on your own. Okay, hopefully you noticed that this is in the form ax plus by equals c. A, b, and c were all integers. This second one would have been a no. Why? Because first off, the x and the y aren't on the same side. We have to have our x term and our y term on the left, and they have to be equal to some integer. So that doesn't fulfill that end of it. This next one fulfills that part of it. It has the x and the y on the same side. However, my coefficient of my y value right here is not an integer, so that would be a no as well. And lastly, you might have been tempted to write no. However, this is in fact in standard form. What happened is my b value was 0. Remember, both a and b can't be 0, but one of them can be. Okay, and we're going to talk about this type of line where x equals some integer or y equals some integer. We're going to talk about that a little later in today's lesson. So now we're going to show you how to convert equations into standard form. So let's watch a quick video here from the SAS curriculum.
Let's look at how to convert these 2 equations from slope-intercept form to standard form. We can write the equation y equals negative 4x minus 8 in standard form by moving the x term to the left side. Add 4x to each side. So the equation in standard form is 4x plus y equals negative 8. Now, let's write the second equation in standard form. Since the equation has fractions, we need to first multiply both sides of the equation by the least common denominator, 6. We can then simplify. Now we can move the x term by subtracting 2x from each side. So this equation in standard form is negative 2x plus 6y equals 15.
Okay, I want you to notice what they did right here. I didn't want you to get lost here. The 6 times 1/3 would be 6 over 3, which is 2. So I'd be left with 2x. And then we're distributing here, right? So 6 times 5 over 2. 6 times 5 is 30. Divided by 2 is 15. So I didn't want you to get lost there in that particular spot. So anyway, let's go ahead and do a few of these on our own. These next 4, I'll go through them with you as we go. Just kind of step you through this. The first thing I want to look at here in this first one is I've got a fraction. I need to get rid of that fraction. How do I do that? I multiply everything by the denominator. So I am going, again, I'm not going to write everything out, but I will verbally talk you through this. I'm going to multiply everything in this equation by 3. So I multiply the left side by 3. I'd have 3y. 1/3 times 3, the whole point was to get rid of the 3, right? So I'm left with 1/3 times 3 would be just 1, so I'm left with a 1x. Now, 6 times 3 would be 18, right? So now all I have to do is get my x and y on the same side. I would do that by moving the x over here by subtracting it. So I would end up with negative x plus 3y equals 18. Okay? Now this next one. Again, I've got fractions right away. So I know I'm going to need to multiply by something that will get rid of, I could multiply by something that would just get rid of one of them. But why do something twice when I could just do it once? What's a number that I could multiply by that would get rid of both the 4 and the 5? Hopefully you come up with the number 20. So I would take everything times 20. 20 times y, 20y. 20 times a negative 1/4. I'll just tell you right now, if you think you have trouble doing that mentally, put it into your calculator. Myself, I just look at it as having 20 over, or a negative 20 over 4, which is going to leave me with negative 5x. And 20 times 3 over 5, the 20 over the 5 would be a 4, and 4 times 3 would be 12. I'm just left with having to move the x over to the y. 5x plus 20y equals 12. Okay. Now, why don't you try to do this next one on your own? Hit pause and ready to go. Okay, now that you're back, I should have known right away I need to multiply everything by 4. So 4y, it would get rid of the 4 here, I'd be left with 3x. 7 times 4 would be 28. Okay, move the 3x over, negative 3x plus 4y equals 28, and that is now in standard form. So all of these were in slope-intercept form, right? Y equals mx plus b. Y equals mx plus b. Y equals mx plus b. This one, however, is not. Doesn't change anything. All I have to do is simplify things, get my x and y on the same side, and I'm still done. So hopefully you would recognize that the first thing I would want to do is distribute the 2. 2x plus 8, and then I'm subtracting 9 out here. And I'm going to do two steps at once. I'm going to move the 2x over, so negative 2x plus y equals, I would have 8 minus 9, which would give me a negative 1. All of those four are now in standard form. Okay. You might be presented with some other information and asking you to write things in standard form. We're going to have to remember back to what we did last time. Remember, we wrote lines when we just knew 2 points. We wrote lines when we knew a slope and a point. Okay, so that's what we're going to look at here. It wants you, first off, to write the following in standard form: a line that goes through 2, 8 and through negative 4, negative 1. So, our procedure here should be to first off write it in slope-intercept form and then convert it to standard form. So, the first thing I'm going to need to do is find out the slope, right? So slope equals negative 1 minus 8, that would be y2 minus y1, and negative 4 minus 2, x2 minus x1, so negative 9 over negative 6 equals a positive 3 over 2. So now I know the slope, I just need to know the y-intercept, so I take one of these points and I'm going to plug it into the slope-intercept form. Y, which would be 8, equals mx, so I have m, I have an x, plus, and I don't know b yet, right? The 3 halves times 2, that would simplify the 2's, right? So I'd be left with 8 equals 3 plus b, so b would equal 5, right? Okay. Let's change colors, because now I know the slope and I know the y-intercept of this line. So let's go write it in slope-intercept form. And now all I need to do is convert it to standard form, which is a fairly easy procedure. What do I need to get rid of first? I need to get rid of this fraction, so I'm going to multiply everything by 2. 2y equals 3x plus 10. And now I just move the 3x over by subtracting. Negative 3x plus 2y equals 10. Okay? So that would be the procedure you would follow if you've got 2 points. You notice I found the slope, I found the y-intercept, wrote it in that form, and then converted it to standard form. Okay. Now let's write a line that is write an equation in standard form of a line that is perpendicular. Remember that symbol, perpendicular to y equals negative 4/3 x minus 2, and it goes through this point. So, first off, the slope of a line perpendicular to this line, remember the slope of a line perpendicular is the negative reciprocal, so negative, and then the reciprocal of 4/3 is 3/4. And now it's all the same procedure. I'm going to use this point, so y, which is 2, equals negative 3/4 times x, which is 6, and I don't know my y-intercept. So 2 equals negative 3/4 times 6 is going to simplify to negative 4.5, or negative 9 over 2. Remember, just because I have a fraction, it's no big deal. This is just negative 4.5. I add that over, I should get b is equal to 6.5, or if I'm a fraction person, that would be 13 over 2. Okay, you can write that as 6.5 or 6.5. I don't mind. The problem with writing it as 6.5 is you're just going to have to go back to the improper fraction form, because in standard form, remember, we want it as a whole number or an integer. I'm sorry. So I'm going to have to get rid of that too. That's why I leave it in fraction form, because I don't like to go back and forth. So I'm going to write this equation. Y equals, my slope is -3/4. Then we have x plus 13/2 is what I found the y-intercept to be. I should notice that in order to write this in standard form, I've got to get rid of both a 4 and a 2 so I can multiply everything by 4. 4y equals, I'd end up with -3x because the 4's would go away. 4 over the 2 would be 2, so I'd end up with 2 times 13, which would be 26. I simply move my x and y to the same side, and I end up with 3x plus 4y equals 26. Okay. Alright, and that's the procedure for going into standard form when we're talking about the equations. What we're going to go into next is kind of the most useful part of having things in standard form, and that's graphing the line. It can end up being very easy for us to graph these lines when they are in standard form. So let's first look at some concepts we need to know about. The x and y intercepts. We should know that those are points where a line is going to intersect. Whoops, I'm going to go back to blue. Sorry. Going to intersect the x and y axis. So the y-intercepts, remember, we're talking about points here, so I need to be able to list an ordered pair. Well, a y-intercept is always going to have an x value of 0, because I don't go right or left any amount, right? I just stay right where I'm at, and then I'm just going to go up or down whatever that y value is. Same concept for an x-intercept. I am going to stay on the x-axis. I'm going to have to go right or left some x value, but I'm going to go up or down 0. I'm never going to move up or down if I'm talking about the x-intercept. Okay? So here are your steps to graph when having something in standard form. I'm going to find that x-intercept by subbing 0 for y and then solving for x. Now, some people get this confused, but it makes sense when I look up here, right? For my x-intercepts, what is my y value always going to be? It's going to be 0. So to find my x value, I want to plug in 0 for y and solve for x. Okay? So initially it might look a little backwards, but when you give it some thought, it makes sense. I would be kind of getting rid of this y value by plugging in 0 for it, and then I just solve for x. And be vice versa here, solving for y, I'm going to plug 0 in for x and solve for y. Once I have those, I'm going to plot my intercepts, and then I will draw the line, because once I plot my intercepts, I'll have 2 points, and I can go ahead and do that. So let's again look at another video here just to make sure we can pick out the x and y intercepts. I guess this isn't really a video, but I want you to look at each graph below and think about what the coordinates are for the x and the y intercepts. So just think to yourself, what are my coordinates of this point right here? Okay, and what are my coordinates of this point right here? Think about an ordered pair for each one of them. Okay. The ordered pair for this and the ordered pair for this. Hopefully you came up with an x-intercept of 4, 0 and a y-intercept of 0, 6. It's very important that you have those in the correct order. Okay? My x-intercept, I'm going to move over x units, or 4 units, up and down 0. You can't have these reversed. Okay? It's very important. What about this one right here? My x and y intercept. Well, it crosses the x right here and it crosses the y right here. So hopefully you notice that my x and y intercept for this one are both going to be the same, and those are at the origin at 0, 0. Okay. Let you look at this last one. Hopefully you notice right away, hey, I don't have an x-intercept, but I have a y-intercept at 3. So I would have a point at 0, 3, an x-intercept. Okay? There is no x-intercept because it never crosses. Okay? It has a slope of 0, and it will not cross that x-axis. Okay. Now, using these to graph, if an equation is in standard form, we can easily find the x and y intercepts to graph a line. Again, I'm going to go to this video real quick, then we'll do a couple examples, but I'll let you watch this first.
In order to graph the equation 2x minus 3y equals negative 6 using intercepts, we first need to find the x-intercept. Since the y-coordinate of an x-intercept is always 0, substitute 0 for y and solve for x. So the x-intercept is negative 3, 0. For the y-intercept, we know that the x-coordinate is always 0, so substitute 0 for x and solve for y. So the y-intercept is 0, 2. Now we can plot those intercepts and draw the line.
Okay, so pretty simple. Whenever we can introduce a 0 and get rid of part of an equation, make it easy on ourselves, we will do that. Okay, so let's look at these examples right here. The first thing we are going to do, let's find the x and y intercepts of this one right here. Okay, in order to do that, we'll find I'm going to use red here, the x-intercept, sorry. I'm going to plug 0 in for y, right? So I'm going to have x plus 4 times 0 equals 8. So that makes that go away, right? That term right there, 4 times 0 is 0. So simply x is going to equal 8, right? So I'm going to end up with, whoops, so I've got x equals 8 right there. So I've got a point at 8, 0. That's my x-intercept. My y-intercept, I'm going to plug 0 in for x. So 0 plus 4y equals 8. And now y, since that goes away, I just have to divide by 4. Y equals 2, right? So I'm going to have a point at 0, 2. So 8, 0, 1, 2, 3, 4, 5, 6, 7. We're going to say it's about right in there. How's that look? And at 0, 2. Dash it. So, make it red to match. Not bad for the first time right there. Close enough. Okay? Now I'd like for you to go try this one on your own. This next one. Okay, now that you're back, hopefully to find the x-intercept you knew to plug 0 in for y equals 20. So I've got 8x equals 20, and if I divided 20 by 8, I simplify that, that goes down to 5 over 2, right? So I would have an x-intercept at 5 over 2. If you want to put 2.5, that's fine. Doesn't matter to me. For my y-intercept, intercept, remember I'll plug in 0 for x, so 8 times 0 plus 5y equals 20. So 5y equals 20, which means that y equals 4, and I've got a point at 0, 4. Okay, so 2.5, 0, 1, 2, about right there, 0, 4, 1, 2, 3, 4, about right there. Connect my points. That's not very good. That's not bad. Okay. And finally, we'll go find this next one. You should notice right away this is not in standard form. In order to make your life as easy as possible, I'd recommend writing it in standard form. I want to get the x and the y on the same side. So you could do one of two things. You could move the x over here and move the 18 over here, or you could just know that all you have to do is move the y to the x. Either way, you'll end up with 4x minus 3y equals 18. If you move the x over and the 18 over, all these would end up being opposites. So this would have been a negative, this a positive, and this a negative, which is perfectly fine. It's the same equation. Okay. As we work our way through this, our x-intercept, we know we plug in 0 for y. So 4x equals 18, x equals 18 over 4, which we know is 9 over 2, or 4.5. Okay, so I've got 9 over 2, 0 for a point. And when I find my y-intercept, I plug in 0 for x. So 4 times 0 minus 3y equals 18. So negative 3y equals 18 gives me y equals negative 6. So I have a point at 0, negative 6. So 9 over 2 is 4.5. 1, 2, 3, 4.5, about right there. And 0, negative 6. 1, 2, 3, 4, 5, 6. Move it over just a hair. Not quite that much. Takes some practice getting used to all these. Okay, so there's my line. Alright, so hopefully you realize the usefulness of the standard form here. Makes it pretty easy to graph. Some people like this better than slope-intercept form. They don't have to really do any counting. They can just plug in, find a few points. You know, a lot of times you can, if it's an easy enough equation, you can just do this mentally and figure out what the y-intercept and x-intercept are going to be. Okay. Moving on, a couple special cases that I told you we would come back to. Graphing horizontal and vertical lines. Let's start looking here. A horizontal line will be in the form y equals a, where a is any number. Okay? So a just has to be any number. It can be a whole number, fraction, any type of number you want. Okay? So when I just have a y and it's equal to a number, it's going to be a horizontal line. Alright. A vertical line will be in the form x equals a, where a is any number. So a vertical line is x equals some number. Alright? People get this confused. Flat out, they don't, I don't think that people generally take the time to understand why these are the way they are. Okay? So here's the deal for this line. All you really have to think about is where your intercept is. Okay? So if my intercept is on the, which axis is this? The y-axis. Okay? If my intercept is on the y-axis and I don't have an x-intercept, then that means that my equation is going to be y equals whatever this intercept is. Likewise, which axis is my intercept on? My axis is on, or my intercept is on my x-axis. Therefore, my equation will be x equals whatever this intercept is. As long as you simply remember it that way, then we shouldn't have any issues. Okay, so let's try to write the equations of all of these graphs down here. Start with the red graph, which will be right here. Okay, I know you can't see on your paper, but you can see on the video. Well, that has a y-intercept, so I should know that that is going to be y equals, and what is my intercept? 1, 2, 3, 4, 5. So that is y equals 5. Let's go down to this green one. Again, that has a y-intercept and no x, so that's going to be y equals, and I went down 2, right? The blue line, okay, that has an x-intercept. 1, 2, 3, 4. I move left 4, so that would be x equals -4. And the purplish pink color that I don't know how to describe is again an x-intercept and a x equals 2. Okay? Now the last thing I want to go over with you today is an inspire and how you can, if you recall from last time, the inspire, we everything was in function notation. Remember? So if we had it in slope-intercept form, that was okay because it was f1 of x equals, or f2 of x equals, or f3 of x equals. But we can also write it in standard form. We can change that function notation to standard form. And how you do that is you open up the graph, okay, and once you have a graph open, you can hit the menu button, okay, and then after you hit menu, you get a list, okay, and you'll see a number 3 that says graph entry edit. That will give you another list which will let me follow along here so I don't mislead you. And that then you will need to choose the number 2, which says equation, and then you will choose 1, which says line. We're dealing with lines here, right? And after you do that, you'll see it has number 1 is y equals mx plus b. Number 2 is x equals c. Number 3 is ax plus by equals c. So if you want to be able to graph something in standard form, you just choose the number 3, and then you'll be able to fill in a, b, and c and graph those equations. Now, if you ever want to graph a vertical line, you go through the same steps. Choose 3, 2, 1, but then remember on that list there was one that said x equals c. That's just a notation difference. We listed it as x equals a up here. Still, x equals c on the TI Inspire is the same thing, so you would choose number 2. All you have to do is fill in that value for a, which shows as c on the Inspire. Okay, and now you should be ready to have success on your practice problems for lesson 3.3.